Today we are talking about lesson 31, flowchart and paragraph proofs. This is part 4. Our question for part 4 is prove theorem 5-4. If two lines are perpendicular, then they form congruent adjacent angles. We are given that line S and T are perpendicular. Angles 1 and 2 are congruent adjacent angles. So now we are talking about, so paragraph proof is good for short proofs where each step follows logically from the one before. Paragraph proofs are usually more compact than two-column proofs. So here it's asking us to prove theorem 10-1. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. You are given that lines P and Q are parallel. You're trying to prove that angle 2 is congruent to angle 3. It is given that lines P and Q are parallel. So here, for the paragraph proof, it does in fact start by saying that it is given. It is known that angle 1 is congruent to angle 3 by the corresponding angles postulate. That's postulate 11, postulate from the 11th lesson. This is these two units here, corresponding angles postulate. By vertical angles theorem, angle 2 is congruent to angle 1. So we know that these two, because it forms an X, it is a vertical angle, or it is a vertical angle. So by the transitive property of congruence, so this is transitive property of congruence, we know that angle 2 is congruent to angle 3. So there, because it is a very short proof, it makes some amount of sense to do that as a paragraph proof. So here we have prove theorem 5-4. If two lines are perpendicular, then they form congruent adjacent angles. So we have, I'm going to start off with the two-column proof because that's what I would expect somebody to use. And then we can also turn this into a flowchart proof and a paragraph. So we have, we're given that lines S and T are perpendicular. S is perpendicular to T. Is given. We know that angle 1 is equal to 90 degrees. We know that that is true because it is the definition of perpendicular. We also know that angle 2 is equal to 90 degrees because of the definition perpendicular. We clearly see that they are adjacent angles. So we know that, sorry, the measure of angle 1, the measure of angle 2. So we now know that the measure of angle 1 is equal to the measure of angle 2. Now, here is where you kind of have a choice, because we can say that these are equal to each other because you're going through 90 degrees, which will give you the transitive. We also have the other method where we have, here we have 90 degrees, and we know that that is equal to measure of angle 2 from our second one. So this could also be the substitution property. Both of them are equally right. The transitive property is a specific case of the substitution property. So it really doesn't matter which one of these you use, you just need to pick one. So pick one. You don't need both of these because it is the exact same thing. I would argue that the transitive property is more correct because it is specifically using that, but once again, the transitive property is a use of the substitution property. So it's really up to you how you want to do it, which one of these you want to use. So now we have that angle 1 is congruent to angle 2 by the definition of congruent angles. If you prefer to use the flowchart proof, you have S perpendicular to T box, and that is given. You then have that measure of angle 1 is equal to 90 degrees. You also have the measure of angle 2 is equal to 90 degrees. So it makes sense to do a flowchart proof because we are doing the same things in tandem. These two lines can be switched. So because they can be switched, we can use a flowchart proof. And this is the definition of perpendicular, which is the same thing over here, definition of perpendicular. We then have these two coming together to say that measure of angle 1 is equal to the measure of angle 2. I'm just going to pick one for this, and I will do the opposite for the paragraph proof. But we have the transitive property of equality. Now we have angle 1 is congruent. Oops, let's move that down a bit, actually. Arrow. Angle 1 is congruent to angle 2. And this is the definition of congruent angles. We now have that. Let's use the text because we can actually use the text. Line S is perpendicular to line E. So angle 1 and angle 1 is equal to measure of angle 1. Measure of angle 1 is equal to 90 degrees. And measure of angle 2 is equal to 90 degrees by the definition of perpendicular lines. That's this step just in one sentence, these first two steps in one sentence. By substitution, measure of angle 1 is equal to the measure of angle 2. Angle 1 is congruent to angle 2 by the definition of congruent angles. How you choose to do your proofs is completely up to you, but this is how you do flowchart proofs and paragraph proofs. This is the end of lesson 31.